Hello, my name is Diaz, and today I'll be talking about the phases of carbon dioxide. To start, I want to start with what is a crystal lattice? It's a 3D arrangement of atoms in a crystal structure. And as you can see, we can have more than one type of crystal structure. We can have simple cubic, we can have body-centered cubic, we can have face-centered cubic. And they differ from one another in their coordination number. And it's basically the number of neighboring atoms to a specific atom. So for example, in the body-centered cubic, you can have 4 atoms on the top and 4 on the bottom that are neighboring this middle atom. And you can see that on the face-centered cubic, you're going to have more neighboring atoms to a specific atom, and in the simple cubic, you're going to have less. So this relationship is done in a small volume that allows us to predict the material properties, and this small volume is called a unit cell. It's the smallest section of a crystal lattice that is repeated through the crystal structure, and you can think of it as a monomer in a polymer. So basically, if we are able to analyze how the structure of a material is in this small scale volume, then we can predict the property of the material throughout the whole body of the polymer. So what does this have to do with CO2 and the phase diagram of CO2? So basically, this would allow us to predict the phase diagram of solid carbon dioxide through their crystal lattices. And normally, a phase diagram that we've been used to looks like the one on the right, where you have pressure on the y-axis, and then you have temperature on the x-axis. You have gas, liquid, solid phase, and then you have the supercritical region. And the one for carbon dioxide is a little bit different, where the y-axis is temperature, pressure, and this in the x-axis, which allow us to focus on this solid region. And in that same solid region, we can have a molecular phase, an intermediate bonding phase that acts like a transition state, and then we can have amorphous or non-molecular phase on the right side. And I'll be focusing on phase 2, which is a transition phase when temperature is increased from phase 3. And basically, here are the crystal lattices. Crystal lattices, as I said, are dependent on temperature and pressure. Therefore, like the phase changes can be predicted based on this crystal lattices. And among the 3, the one I decided to model is phase 2. Phase 2 occurs at higher pressures and temperatures, as you saw, higher than phase 3, and is an intermediate solid step. It's a pseudo 6-fold structure with an unclear tetragonal to orthorhombic structure, which means it's pretty complicated. But from the article, it looks similar to what we covered in class, which is the body-centered cubic structure, but instead of having 1 atom, it has 3 atoms. So based on this, I decided to model this, and you can see it here. Basically, I have my model in here. I have my model in here, and you can see how all the atoms are in a 45-degree angle with each other, the ones at the top and the ones at the bottom, and then the one in the middle is also in a 45-degree angle, but going a different direction. So as you can see, I was able to model the one in between as by doing the supportive structures, as the atom cannot just be like flotating. So yeah, this is my model. I hope you liked it. CO2 solid phase can be seen here.